All right, let's dive straight into this explainer where we're going to completely dismantle the idea that sleep is just some passive state of turning off. For a really long time, we've basically viewed sleep as this inconvenient biological pause button. But as we dig into the scientific literature today, it reveals a completely different, absolutely fascinating story. We're going to explore the unified biological framework of sleep, and you'll see exactly how mastering this nightly neurometabolic symphony is literally the ultimate lever for your longevity, your emotional resilience, and your overall health span.
So I want to start by challenging a pretty massive misconception right out of the gate. Is sleep just passive downtime? Like, are you just lying there doing nothing? Absolutely not. The research reveals that sleep is actually this incredible neurometabolic washing machine and a highly critical autonomic performance enhancer. When you close your eyes, your biology doesn't shut down, it shifts gears. It moves into a highly active, molecularly coordinated state of recovery, memory consolidation, and cellular repair. It's essentially your body's ultimate survival mechanism.
Section 1. The two-process sleep model, the macro triggers.
To really grasp how this whole biological symphony begins, we first have to look at the macro-level triggers. Like, what actually forces us to get tired in the first place? Well, sleep is governed by two interacting forces, a system scientists call the two-process model. On one hand, you've got process C. This is your circadian clock, a 24-hour rhythmic signal tied directly to the light-dark cycle of the sun, and it's governed by this tiny region deep in your brain called the suprachiasmatic nucleus. Then, on the other hand, you have process S, which is your homeostatic sleep drive. Think of it like a chemical pressure gauge. Every single time your cells burn energy, they release a molecule called adenosine. So the longer you stay awake, the heavier that adenosine pressure gets.
Now, when that homeostatic pressure from process S builds up and crosses a certain threshold, and it perfectly aligns with the circadian timing of process C, a very specific, localized circuit in your brain takes action. It's called the ventrolateral preoptic nucleus, or VLPO. And this area acts literally like a physical flip-flop light switch. Once it's triggered, sleep-promoting neurons rapidly inhibit your brain's arousal networks. It literally unplugs the systems keeping you awake, launching you rapidly and safely into stable sleep. But, and here's the catch, if you're chronically stressed, your sympathetic nervous system aggressively fights this switch. That exact biological tug-of-war, that is the root cause of insomnia.
Moving right along to Section 2, Memory and Synaptic Remodeling, the Neural Architecture.
Okay, so what actually happens inside your head once that switch is flipped? Well, your brain begins this highly structured, intensive process of essentially editing your entire mind. In lighter N2 sleep, we see these things called thalamocortical sleep spindles and massive K complexes. They act as sensory gatekeepers, literally shielding your brain from the outside world so you don't wake up at every little sound. Then, as we drop deeper into N3 sleep, slow delta waves take over to drive deep physical restoration. And coincident with those are sharp wave ripples, these spectacular rapid electrical bursts that literally replay the memories of your day, transferring them from short-term storage in the hippocampus straight to your neocortex's long-term hard drive. Finally, REM sleep sweeps in, with theta rhythms, to emotionally tag and integrate all those newly saved memories.
And this brings us to a fascinating concept, the synaptic homeostasis hypothesis. Think of your brain during the day as a giant sponge, just soaking up every single interaction, creating millions of new synaptic connections. If that just kept happening unchecked, your neural networks would physically run out of space and energy. They'd completely saturate. So sleep steps in as a selective editor. Through a process called synaptic downscaling, it reduces the strength of all the noisy, less important connections you made that day. At the exact same time, it selectively preserves and strengthens the essential connections, the ones that support critical learning and motor memory.
This actually leads perfectly into a profound quote from sleep researcher Giulio Tononi. He says that sleep is the price the brain pays for its neuroplasticity. If we are going to learn, adapt, and literally rewire our brains during the day, this synaptic downscaling at night is the mandatory metabolic tax we have to pay. Without it, our brains just overload, our focus completely shatters, and over the long term, cognitive aging drastically accelerates. Sleep isn't a luxury. It is the non-negotiable tax for maintaining a high-performing mind.
Section 3. The brain's glymphatic wash, micro-level cleanup.
But this brings up a massive biological mystery. If the brain is doing all this heavy lifting, remodeling synapses and burning up metabolic energy all day long, how on earth does it deal with the incredible amount of cellular waste it generates? For decades, scientists didn't really know, because the brain doesn't have a standard lymphatic system like the rest of the body. But in a totally groundbreaking 2012 discovery, researchers finally found the answer. They realized that during deep sleep, The brain's glial cells, specifically astrocytes, actually shrink their physical volume by up to 60%. Let that sink in. 60%.
This extreme shrinkage kicks off what's called the glymphatic system. Here's how it plays out. Step 1. As you enter deep, non-REM sleep, your levels of the wakeful neurotransmitter norepinephrine completely plummet. This drop triggers Step 2, where the astrocytes shrink, radically expanding the empty space between your brain cells. That leads to Step 3. Your brain's vascular pulsations physically pump cerebrospinal fluid right through specific water channels called AQP4. This allows the fluid to literally power wash through the brain tissue, clearing out dangerous metabolic byproducts, most notably amyloid beta, which is the plaque heavily associated with Alzheimer's disease. The crazy part? Your brain literally cannot think and clean itself at the same time.
Section 4. Hormonal and autonomic regulation, the systemic cascade.
Now, this massive nightly cleanup operation isn't just happening up in your head. As your nervous system downregulates into this deep restorative state, it triggers a huge endocrine cascade throughout your entire physical body. For instance, a staggering 70% of your daily growth hormone is released almost exclusively during deep, slow-wave sleep. This hormone is essentially your body's ultimate anti-aging and recovery tool. It's absolutely vital for tissue repair, fat metabolism, and muscle recovery. So if you're cutting your deep sleep short, you are quite literally robbing your body of its primary mechanism for physical repair.
When we actually compare a well-regulated sleeper to someone experiencing chronic sleep deprivation, the contrast is just stark. A healthy sleeper enjoys parasympathetic dominance, meaning they're in a profound state of rest and digest. Their cortisol naturally peaks in the morning to wake them up and then drops to near zero at midnight. But in a sleep-deprived state, the nervous system locks into sympathetic fight-or-flight overdrive. Cortisol stays chronically elevated in the evening, which actually breaks down muscle and promotes visceral belly fat. On top of that, the immune system misfires, spiking inflammatory markers. It's a really destructive shift from a restorative, healing state to a highly inflamed catabolic one. And honestly, the impact on your metabolism is terrifyingly fast. Studies show that even just 2 consecutive nights of restricted sleep can drastically alter how your appetite is regulated. It spikes your hunger hormone, ghrelin, by 24%, and at the same time, it plummets your satiety hormone, leptin, by 18%. So when you're tired and reaching for junk food, this isn't a lack of willpower. From an evolutionary perspective, your sleep-deprived biology literally thinks it's in a life-or-death energy crisis, driving these severe, irresistible cravings for calorie-dense, carbohydrate-rich foods.
Which brings us to Section 5, chronotherapy and optimization, real-world applications.
So, knowing all this incredible biology, how do we actively intervene to regulate our nervous system in the real world? Well, one of the most fascinating examples of circadian misalignment is found in ADHD. The literature shows that up to 80% of adults and children with ADHD suffer from delayed sleep-wake timing. Objective biological markers show their dim light melatonin onset is physically delayed by 45 to 90 minutes compared to neurotypical individuals. They also have severely blunted cortisol rhythms. This strongly suggests that for a huge portion of people, ADHD has a profound circadian and sleep deprivation component that is actively exacerbating the core symptoms of inattention and impulsivity.
But here is the really empowering part. We can fix this. We can take back control of our biology. To combat these genetic predispositions and delayed sleep phases, clinical chronotherapy protocols utilize a very strict daily timeline to manually re-anchor the body's clock. It starts right at 7 a.m. with immediate bright light exposure that halts leftover melatonin and spikes your healthy morning cortisol. Then around 3 p.m., targeted exercise is used to build up process S. Remember that homeostatic adenosine sleep pressure? By 8 p.m., strict light restriction and screen hygiene begin, massively reducing stimulation to prime that VLPO flip-flop switch. Finally, at 10 p.m., targeted, low-dose melatonin can be used to advance the circadian phase. By simply controlling your light exposure and behavior, you can physically force your biological clock back into alignment.
So now that we've explored all these hidden mechanisms together, the cellular washing machines flushing out disease, the synaptic editing suites optimizing your memory, and the massive hormonal cascades that dictate your metabolism and your longevity, the reality is pretty undeniable. Sleep isn't some passive luxury. It is the absolute foundation of human performance and health span. The compounding biological interest of a good night's sleep over a lifespan is staggering. So the only real question left to ask is, knowing all of this, how will you prioritize and re-engineer your own routine to harness this neurometabolic symphony tonight?